Okay, we are going over 3.5, equation solving and modeling. This has to strictly do with logarithms. This is not, typically when we talk about modeling, we talk about story problems. We're not going to go over that today, we'll do that tomorrow. Right now we're strictly going to have equations, and when you have an equation, what's the main goal?
Get x by itself.
There you go, let's get x by itself. Alright, first thing we want to do is, in order to do that, you always want to, one of two things, have all the logarithms on one side, or the log of the same base on both sides. But right now we have a logarithm. So
There's two logs in there. Can you combine those?
Or
no?
not necessarily, no. Okay, if you have a logarithm, you want to change it to an exponential function. And if you have an exponential function, you want to change it to a logarithm. And then that's typically how you can solve them. All right, let's start with this first one. How do I change this to exponential? Maybe we should write our two rules up here. Base is always the base. And the second rule is that logarithms, no matter what, equal exponents. Those are good rules. All right, we got those up there. So taking a look at this first equation right here, logarithms equal exponents. What is my exponent?
4.
No, logarithms equal -1. So this part is the exponent. This part is the base. Okay? So I end up with 4 to the -1 equals x minus 5.
So you can just put the 4 over there, no problem.
No, I'm actually changing it to an exponential function. I'm just rewriting it. That's all I'm doing to it. Okay?
Shouldn't it be on the other side?
I'm rearranging it.
Okay.
So it doesn't matter. I mean, yes, I could have written it like x minus 5 equals 4 to the -1, but it doesn't matter.
What about the sign changes though? If x minus 5 is on that side, then shouldn't it just, shouldn't it be negative x plus 5?
No. No. Okay. The other way I could have written it is this way. It doesn't matter. See, there's an equal sign.
Alright.
Okay. So is x by itself? That's my question.
No.
No. Evan, what's my next step maybe to get x by itself? No? Okay. Anyone?
Plus 5.
Okay, gonna add 5. All right, 4 to the -1, guys. We need to kind of come up with what is 4 to the -1 equal. No, it does not make it negative. Eli?
It's 1.
What?
No, wait a minute.
Oh, okay. It's
Sure.
1/4.
What do you mean?
That's 1/4. Yeah, 1/4.
Oh,
It's when you have a negative exponent, it just means that it goes into the denominator.
Yep.
Wait, so it's 4 to the -1. 325.
Okay? All right, let's try to continue on. We'll do a couple more examples. Now in this next one, the logarithm, you must isolate the logarithm first. So before we change it to exponential, you guys, we've got to get the logarithm by itself. So what's the first thing that you want to do? We're peeling away to get to the x. Christian, what do you think? No? Simon? What, just any steps, like if you were just doing... We could divide by 3, but I think I want to get rid of that 4 first. Yep, so we're going to minus 4.
Wait, I thought you just said to get the logarithm by itself.
Yep, we're trying to get this logarithm right here by itself. So we have to get rid of the 4 first. like, if I had 3x plus 4 equals 5, if I had that, I'm not going to divide by 3 first. I mean, I could, but it would make it messier. I'm going to subtract 4
How
first.
come above we didn't get x minus 5 or whatever?
Because all of the x minus 5 is in parentheses, which means it's connected to the logarithm. All of this x minus 3 is connected to the logarithm.
So you could divide by 3 first.
Oh, if you divide by 3 first, you also have to divide this 4 by 3. It just makes it longer.
Alright.
But technically, yes, as long as you do everything mathematically correctly, you can. All right. Now, what's the next step? Now we're going to divide by 3. Okay. Now I've got the logarithm all by itself. So now what do? I change it to an exponential function. Okay. All right, now take a look at this. Anyone who has not answered in a while, what is the base of a natural logarithm?
10.
It's e, yes. 10 is the common logarithm. Base is e. So my base is e. Logarithms equal, so it's e to the 1/3 equals x minus 3. And then what would my last step be?
Add over 3.
Yeah.
So that's your answer.
That is. Now, you could certainly get your calculator out and you could, type it in and then try to do it that way, but, get a decimal answer, but that's perfectly fine answer. All right, now number 3 and number 4 are a little bit different. Number 3 and number 4 are like this right here. You have to change it from exponential to a logarithm. So, before you do that, you have to get the exponential function all by itself. All right? What around this exponential function needs to go away? The 80. So let's divide by 80. And 240 divided by 80 is 3. Alright, so let's change it.
Get 3.
How did I get 3? 240 divided by 80.
Alright.
Okay, now the next thing is, I need to know what x is. And I said up here, when you're questioning what x is, you change logarithms to exponents. But now we're going to change this exponential function to a logarithmic function. Okay? So I'm going to write down, what logarithmic function has a base of e? Alright, so we have the natural log, we got the base part, and logarithms equal what again? Exponent. And what is my exponent? My exponent is 0.045x. So then what goes next to the logarithm? The 3. X, not quite by itself. What should I do? Divide.
Is there a logarithm with pi as the base?
No.
Why not?
I just don't believe that it models anything that is, worth repeating. A common logarithm is used quite a bit. The Richter scale, it's used for decibels and intensity and light. And the natural logarithm is used a lot to model population growths and things in nature. Let's say having a log of base pi is as arbitrary as having a log of base 5. It just doesn't, it's used maybe specifically for something, but not always.
Well, E is similar to pi. Since they both repeat forever, don't they?
Well, yes, but that's like saying 1/3 and 1/7 are similar. They're both decimals that repeat forever. So yes, they are irrational numbers, but they mean a lot. They are used differently.
So, can you think of any example at all where you might want pi as the base of a logarithm?
No, not exactly. No,
Okay.
no, because I would never do pi to a power. I don't think. No, I wouldn't.
Right.
So, all right. Number 4 here. What do I need to do first before I can convert that? What do you think I should do first? Yeah, let's get the 7 over. So I've got a negative 3e to the negative x equals negative 5. Wow. Next step, I divide by negative 3. I have e to the negative x equals 5/3 because the negatives will cancel. Be careful. Don't write those as decimals. I know that fractions seem not nice, but leave them as fractions. It's a much more accurate answer. Okay, so now I have an exponential function. The variable's in the exponent, so I need to change it to a... Alright, and so what logarithm has a base of e? Natural log. So it's going to be the natural log 5/3 equals negative x. Yes, you can times it or divide it by negative 1. Right. So x finally does equal negative natural log of 5/3.
In natural log, is the L capitalized, or is that just your cursor?
No, it's a small l, and it's Latin for logarithmic natural. That's why it's, we say natural log, but in Latin it's switched around. That's why.
And that's why you don't take Latin. No, I don't even pray to that tonight.
Oh, do you? Yeah, no, it's a small l.
Oh, you're taking Latin with some logs.
I think it's
Okay, you're good.
Latin.
What?
I would like to take Latin.
I get it. I don't know. I took it freshman year. It was not incredible.
Ooh, probably pretty different. Did you get that, Blake?
Yeah.
All right, couple more, guys. Okay. All right, now in this one right here, we've got 2 exponents. Okay, does anybody have any ideas of how to solve this one?
Logarithms equal exponents, so.
I guess we could change it to a logarithm. One of the things that I would do when you've got something along this line, how are 2 and 8 related?
They both have the
power. 2 out there is power out.
There you go. All right, 2 to the 3rd equals 8. So let's replace the 8 with 2 to the 3rd.
And you can cancel bases,
Not quite. What I need to do next is I've got to, multiply that in first. So I'm going to do that. I'm going to multiply the 3 times that. Don't forget to multiply the 3 by the 4 also. Oops, forgot my 2. Okay, now I heard somebody say we can get rid of the bases, correct? When they're the same? Alright, so if I get rid of the bases, what am I left with on the left?
0.
What is the power on this 2?
1.
It's a 1. So you are left with 1 equals 3x minus 12. And then just solve that algebraically. Add 12, divide by 3.
I didn't know you could just get rid of the bases like that.
Well, if you think about it, hang on.
Because they don't have the same values, so how can you just say, hey, they're the same, so...
Okay, because if I have 2 to the 6th equals 2 to the x, the only way that these two are equal is if that value right there is 6, right?
Yeah.
So that's like saying, okay, well then 6 equals x.
Alright.
And,
Makes sense.
yeah, and it could be, and this one was obviously a little more complicated, but in order for these two to be exactly the same, x would have to be 13/3. So if I put 13 thirds right in here, 13 thirds times 3 is 13. 13 minus 12 is 1, and then therefore they're equal. Okay?
That makes sense.
Yeah, it does look kind of like, oh, is that cheating by just canceling them out? But you're not. Okay?
Let's go like back to what we were doing, I forget what it was. It was like last chapter.
Yes, a little bit, yep. Now, when you have this particular situation where you have all these logarithms on both sides, what you want to do is, the first step when you have the logarithms is you need a single sigma. Logarithm on both sides.
I thought you wanted all the logs on one side. Can we write that down?
You could do it that way, but in this particular case, what I'm going to do is, this is very similar to what we did right here, and we got it so that the bases were the same. Well, if I can get it so that the logarithms on either side are the same, I set the arguments equal to each other.
Okay.
Okay? So, I need to combine these two. I already have a single logarithm here, but I need to combine these two to a single logarithm. How can I do that?
You
Can
x,
you distribute?
x minus 2 times
No.
x, so yeah, distribute.
Well, this is working backward from the properties. What properties is plus? Is that multiplication or division?
So x minus 2 times x.
Yes. So I'm going to write it all out and then we'll do it.
Distribute it, yeah.
Okay? Everybody all right with that?
No.
This right here is the same. Yesterday we talked about if you have, if you have the log of AB, then it's the same as the log of A plus the log of B. Did you agree with that?
Yeah.
Okay, well all this is we are now we're working backwards. We have this and we're changing it to that. See, they're separated by a plus and we're changing it to that right there.
And then that would be x squared minus 2x.
That's correct. Okay, wait, I need to make sure, does that make sense with everybody? Good? Okay, so yes, this is log same rule applies. In order for these two to be equal, this part right here has to equal 3.
Wow.
Okay? Wait,
Yeah, like that.
how do you solve a quadratic?
Everything to one side.
Very good. Yep, get everything to one side. Subtract the 3. Now what's the next step of solving a quadratic?
AC method.
AC, there's no A in this case, so we just factor it. And what do we factor?
2 and 1.
Yep, yeah, what is it? Well, actually, they got to multiply to make 3.
So it'd be negative 3 and 1. Because the negative 2 is in the middle, and that's the product. The sign.
Yep, and if you think about it, negative 3 plus 1 is my negative 2.
Right, I'm not gonna lie, but that's pretty clear.
Yes. Oh, wait, so now, how many answers am I going to get this time? I'm going to get 2. I'm going to get x equals 3 and x equals negative 1. Now, what should we do usually when we get 2 answers?
Check for extraneous.
Check for extraneous. What is going to make a logarithmic function undefined?
If it equals 0.
Yeah, that's part of it. Remember, a logarithm looks like this. That's right. And what can x's not be? That's right. They cannot be negative because we have no graph there. So, take a look at here, and if x can be negative, as long as when I put it back in here, I'm okay. But it seems to me, if I put negative 1 in here, I get log of negative 1, and that's undefined. So this solution right here is extraneous. And this is right here is my solution. Okay? All right, can I flip? All right, last problem. All right, what should I do next? What should I do first?
Homework. Combine the natural log.
Perfect, combine these. So, natural log of x cubed, x minus 2 cubed equals 0. What should I do next?
Distribute it. Wait, can you?
Yep, in this case, well, now this time we don't have, okay, I can do, well, I cannot distribute, good question, because this is cubed right here. So I have to just kind of leave it just like this. Like,
Aren't there a few ways of doing that? Like you could distribute and then just have it all cubed still?
no, I would have to multiply all this out 3 times, then I could distribute the x cubed in.
You can't distribute first and then.
No, cannot distribute first. Right here, because I don't have logarithms on both sides, I can't do the nice little cancel. So I have to change, it's a logarithm, so I have to change it to exponential. What is the base of this logarithm? E. So this is e, and to the 0 equals, and what does e to the 0 equal? What's anything to the 0 power? Yeah. Okay. All right. And then the next thing that we want to do is
Wait, e to the 0 equals 1 though.
yes, equals 1 right there.
So how do you get on the second step right there where it's x? You would still, how do you get that? How do you get e to the 0 power?
I just carried this down. I changed it to logarithmic. That's the base. Logarithms equal exponents,
Oh, yeah.
and then went from there. Now, in order to solve this, this one is going to get messy. You will have to put everything over. Quite honestly, what I would do at this point is I would put all of this, because it is really messy, into y1 on my calculator, and I would put this into y2. And then after that, I would just find the intersection. Okay? All right, your homework, guys, is going to be on page 331. And let's see. It is going to be 3 to 27 multiples of, no, I already did that one. Okay. 3 to, yes, I know it. 3 to 18, it's shorter.
It's gonna be over what we just did, right?
Yep. Multiples of 3. Okay. And then, how about, let me see if I want to give you the rest of those.
Do you make this worksheet yourself?
No, 28 to 38. Oops. 28. How about 28 to 34 even? All right?